Yeah, good day, everyone. I'm delighted to have you back in class today. I want to believe you had a very nice weekend, and we are back again to class. And I want to appreciate those of us who actually put in their comments in the last class. We talked about a very interesting topic, quadratic equations, and how to solve quadratic equation using the almighty formula. I want to believe that a good number of us also practice questions at home because that's what is expected. You can't do well in maths if you do not have the habit of always practicing and solving on your own. Today we have a very important topic in maths, and the topic I have highlighted it here is rational and irrational numbers. There are some special sets of numbers that we refer to as being rational and irrational. So after this class, we are going to learn and find out those numbers that we call rational and those numbers that are referred to as being irrational. The scope of the lesson has been outlined here below. The first thing we have here is to talk about the meaning of rational numbers. Afterwards, we go into the types of decimals and then follow them down the line until we are able to cover up what we have today. So we have quite a number of things to talk about today. And I want to believe we're going to be able to understand in details all that we have here today. So let's get into it immediately without wasting time. The first thing there is the meaning of rational numbers. Rational numbers are those set of numbers, any number that can be expressed as a fraction. A over B, this is how a fraction looks like. While the number up is referred to as the numerator, and the number down is referred to as the denominator. So, if I give you a number, and you can express that number as a fraction, then that number is referred to as a rational number. So, let's take the definition. A rational number is any number that can be expressed, any number that can be expressed as a fraction. And this is the form of a fraction A over B. That is what we call a rational number. Any number that can be expressed as a fraction. Simply put, there is no other special way of defining a rational number than just what I've given you here now. So we are done with the first thing we have on our scope. The second thing now is the types of decimals. Types of decimals. I have types of decimals. For those who do not know what a decimal is, the decimal number is usually that number that has two parts. It has two parts. A decimal number has two parts. And we say that we have the whole number part. We have the part that we call a whole number, and then we have the part that we call a fraction. Take for instance, if I write 1.28, you can see this number before the decimal point is the one we refer to as the whole number, and then 0.28 is the one we call the fraction. There are so many persons who pronounce a decimal number like 1.28. No. The digits after the decimal point are usually pronounced digit by digit. We don't call them together as if it's a whole number, but you're free to call this as a whole number. So that's what a decimal is. Now, what are the types of decimals? There are basically three types. We have three types of decimals. We're going to learn the three types of decimals we have. The first one is called terminating. We call the first one terminating decimal. Terminating decimals are decimals that have an end. Decimals that have an end. They have an end. They come to an end. For example, 0.5, 1.2, 1.4, etc. So whenever you make a conversion and then you have a decimal that comes to an end, we call that decimal a terminating decimal. The second type of decimal is the one we call recurring decimal. These are decimals that have no end. Decimals that have no end. They have no end. And its digits repeats. So it has repeating digits. Each digit repeat. I know many of us have actually pressed something in the calculator and you got something like 0.3333 etc. and it just continues to go. So this type of decimals are what we call recurring decimal. And to show that it continues without an end, we usually put in three dots. These three dots in English language is called the ellipses to show that something continues without an end. So recurring has no end, the digits repeat. And then the third type of decimal is the one we call non-recurring decimals. Non-recurring decimals. Non-recurring decimals. How do we know non-recurring decimals? Just the opposite of this. It has no end as well. It has no end. And the digits do not repeat. So you could see now the distinguishing factor between recurring and non-recurring. The digits do not repeat. Digits do not repeat. So when you get something like example 3.1427589 dot dot dot, it just continues without an end, and you notice that the digits do not repeat. We call that type of decimal a non-recurring decimal. So we've been able to highlight the three types of decimals we have, and I want to believe you've taken note of them. We will run along and then get into the next option we have on our scope of the lesson there immediately. The next thing there is how to convert a decimal to fraction. Now, the first decimal, we're going to learn how to convert terminating decimal to fraction. An example of a terminating decimal is 0.5. To convert a terminating decimal to a fraction is very, very easy. How do we do that? I always tell students, remove the decimal point and write all that you see here. If I remove the decimal point, I'm going to see 0.5. Draw your horizontal bar, turn this decimal point to 1, and every other digit after that decimal point, turn it to 0. So we're going to have 0 here. This 0 means nothing. So invariably we have 5/10. And if you reduce this to the lowest term, you see that 5 can divide here and 5 can divide here. So we have 1/2. So I have converted a terminating decimal to a fraction. Let's take another example. 1.2. Convert this to a fraction. Remember what I said? Remove the decimal point and write all the digits you see, which is 12, all over. Turn this decimal point to 1 and turn every other digit after the decimal point to 0. Reducing this to its lowest term, we see that 2 can divide both. So we're going to have 6/5. So we have reduced this to its lowest term and we've converted this to a fraction. So converting terminating decimal to fraction is usually very easy. Everybody can go through that. Then, how do we now convert recurring decimals to fraction? That's where the job comes in. Recurring decimals to fractions. Pretty simple. Now, if somebody gives you 0.333 dot 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 to convert it to fraction, I know one will begin to wonder, how are we going to do it? So you said remove the decimal point and write everything to you see. So invariably what we are supposed to do here is 333 all over, turn this decimal point to 1 and every other digit to 0. But imagine that this digit continues to repeat. So how many zeros are you going to continue to repeat for you to be able to convert this to a fraction? You see that converting recurring decimals to fraction is now a little bit tricky. And there's an approach which I'm going to teach you how we convert a recurring decimal to fraction. So we're going to dwell on this a little bit. So pay attention. Let's get through it. When you are given a recurring decimal to convert to fraction, because it has no end, we are going to do everything possible to try to eliminate that recurring digit, which is 3. The first step you do is note the number of digits that are repeating. How many digits are repeating here? We have only 1 digit. If 1 digit is repeating, you are going to multiply that number by 10. If 2 digits are repeating, let's take for example, have 0.1313, you're going to multiply that number by 100. So the number of digits repeating, you increase the powers of 10 by it and multiply by that number. So we are going to say the first thing is 0.333 times 10. Why are we multiplying by 10? Because only 1 digit is repeating, which is 3. Is equal to, if you multiply this, you see that when you're multiplying by increasing powers of 10, we usually move the decimal point to the right, the number of zeros we have here. So just once, and this is going to give us 3.33. So you see that we have eliminated that. Now, ask yourself what you have just done here. We have done this fraction given to us times 10, and we got this result. We follow the stepwise approach in doing this. The next step is this result you have gotten here, write it down, minus the fraction given to you, 0.33. I know somebody wondering, why are you not repeating it? Because we already have this here, stopped at 33. I'm also allowed to stop it here as well. I don't have to continue to repeat it. It's equal to, if you subtract this, you are going to have just 3. Ask yourself what you have just done here. What we did here was to multiply fraction times 10. So this thing here is really fraction times 10, which was that decimal I gave you earlier, minus your fraction, which will give you what? 3. Now, for those who are used to multiplication of algebraic expressions and all of that, fraction times 10 will give you 10 fraction minus fraction, which is equal to 3. 10 fraction minus 1 fraction will give you 9 fraction, which is equal to 3. And then to obtain that fraction which you are looking for, we said divide both sides by 9. You see that 9 will go, and the fraction you are looking for is equal to 3 over 9, which if you divide or reduce this lowest term, it will give you 1 over 3. So if you press this 1 over 3 on your calculator, you will notice you're going to get 0.33333. Somebody can also try that out immediately. So there are steps you have to follow in converting a recurring decimal to fraction. What is the first step? Find out the number of digits that are repeating, multiply by the corresponding increasing number of 10. Then subtract that fraction from the result you have gotten, and then express whatever you have done in words, and then find the fraction you are looking for. So we are done with this. Now, remember we started with talking about how to convert decimals to fractions. We talked about the terminating, we've talked about the recurring. How do we convert non-recurring decimal? Note this, that non-recurring decimals cannot, so you don't even need to talk about how to convert it to fraction, cannot. Non-recurring decimals cannot be converted to fraction. They cannot be converted to fraction. Okay, so we are done with that. We go over to the next one, how to identify rational numbers. How do we identify rational numbers? Identification of rational numbers. So that if I see a number, I should be able to know whether this number is a rational number or not. How do we identify rational numbers? Very quickly, there are 4 ways to identify rational numbers. Please take note of the ways. 4 ways. Number 1, all whole numbers are rational numbers. All whole numbers are rational numbers. All whole numbers are rational numbers. What are whole numbers? All those numbers you can count. 0, 1, 2, 4, 6, 100, etc. Now somebody is asking, how do we know that these are rational numbers? Because we can express all these numbers as a fraction. How? Remember, a whole number that has no fraction, the fraction is always 1. So as long as I can express all these numbers as a fraction, it means they have both numerator and denominator. We call all whole numbers rational numbers. Okay, the second way of identifying rational numbers, all integers are rational numbers. How do I know that integers are rational numbers? We can also express them as a fraction, but when you talk about integers now, we are bringing in all whole numbers and negative numbers. Whole numbers and negative numbers. Remember that negative numbers are also referred to as integers. So, -2, -3, -4 are all rational numbers. Please take note, because their denominators can be gotten as 1, just like we did for whole numbers. And then the third way of identifying rational numbers, you can guess. Hence, we have said that numbers that are expressed as a fraction are called rational numbers. We have been able to prove how to express recurring decimals as rational number. So obviously, you know what I'm going to say next. that recurring decimals are rational numbers. So take note, recurring decimals are rational numbers. I have proven it here by showing you how a recurring decimal can be expressed as a fraction. So take note, and then example 1 over 3 is here. 1 over 3 will give you 0.333 if I'm not mistaken. And then terminating decimals. We have also proven that we can express terminating decimals as fractions are also rational numbers. So these are the 4 ways. There is no other way to know rational numbers except these 4 things I have listed here. 0.5, 0.6, etc. Okay, and we explained the meaning of rational number, recurring decimals. We also explained the meaning of terminating decimal. So there are 4 ways. Whole numbers are referred to as rational numbers. Integers are referred to as rational numbers. Recurring decimals are called rational numbers, and terminating decimals are also referred to as rational numbers. So we are done with this. How to identify rational numbers? 4 ways. Please don't forget it. Then meaning of irrational number is just the opposite of it. An irrational number is a number that cannot be expressed as a fraction. It cannot be expressed as a fraction. Okay? And you're thinking now, there's just one type of decimal that cannot be expressed as a fraction. You know that? Cannot be expressed as a fraction. And the only type of decimal, so the only example that comes into this place is called the non-recurring decimal. Okay? The non-recurring decimal. Okay, so you can't express a non-recurring decimal as a fraction. We've already said it here. So it falls into a rational number. You can't express an irrational number to a fraction. So we've explained what a rational number is. And then how to identify it. Only one way. They are non-recurring decimals. And of course, these non-recurring decimals are the sorts we know. Remember when we talked about sorts, we told you that sorts are also non-recurring decimals. Root 2, root 3, etc. And don't forget, the common pi, which you know, which is 22 over 7, also falls into this category of irrational numbers. So irrational numbers are numbers you cannot express as a fraction. Their digits repeat, their digits do not repeat, and they have no end. 2 over 7, 3 over 7, 5 over 7, there are many of them, etc. So with that, we come to the end of today's class. I want to believe you learned something very important and significant today. Please like, share, comment so that others can also learn what we are doing here. Help us to spread the good message about what we are doing. This class is powered by First Class Learner Schools, and we'll continue to deliver qualitative teaching anywhere where we are, just to make sure that students do well in their external exams. Thank you for watching, and God bless you.